Welcome, everyone. Thanks for joining us and thanks for being part of our community. My name is Balan Kolika and I'll be your host for today. A few reminders before we start. If you have issues viewing the stream at any time during the presentation and you're using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during this live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. However, in the event if the answer was not provided or if you may have additional questions post the event, please don't hesitate to raise them at Azure Network Security Forum at aka.ms/Azure Network Security Community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. Now, we love to hear your feedback on how we can improve on these webinars, and you can do so at aka.ms/security-webinar-feedback. And by the way, all the links that I'm mentioning have been already shared with you on the chat. That is on the live event Q&A window. I would also like to invite you to join our public community by visiting our community link at aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which, by the way, you can sign up for at aka.ms/security-prp. You can request the features there, give feedback, review our product roadmaps, register for events, or just simply join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Ashish, Kapila, and Anthony Roman will go over the central DNS management and logging with Azure Firewall. Ashish is a senior program manager with Network Security GTP team, whereas Anthony is a lead of the same team. And without further ado, I'll turn it over to them. Ashish, Anthony, the floor is yours.
Thank you, Valen, and thanks everybody for joining us again this morning for the part 5, I think, of 6 Azure Network Security webinars planned for this spring. So I appreciate everybody's continued attendance. We see pretty consistent numbers, and I'm going to assume that a lot of you are the same viewers. So we appreciate everybody. And since Valen mentioned feedback, of course, give us feedback about what the content that we've already delivered and ask us questions and do all those things. But please also use the means that he mentioned to give us, let us know what you want to hear about in the future, because as we're winding down this season of webinars, we're already starting to plan for the next ones. And so just let us know if there's other things that you want to learn about in terms of network security that we can get on our plan for either the summer or the fall sessions. So with that said, let's continue into today's topic. So as mentioned in the title here, we are going to be going through central DNS management and logging with Azure Firewall. It's a pretty specific topic, but I think it's a very important one. We already have a blog written on this topic, which I suggest everybody check out. It's written by Ashish, who will be taking you through the demo portion of today's presentation. And so I'll carry everybody through the concepts and show you a few slides and tell you conceptually what these topics mean in terms of your architecture and traffic routing. And then Ashish will kind of bring everything together with a demo when we're done. So that said, here's the full agenda that we're going to go over. I'll reintroduce Azure Firewall. We've done that a number of times in these webinars, so I'm not going to spend too much time on it. But then we're going to get into the meat of the presentation. It's really only a couple of concepts. We're going to discuss how DNS traffic is routed within Azure and how DNS works in different circumstances in Azure, both with and without Azure Firewall in the mix. And then we're going to go into how we can start using Azure Firewall to control and direct that traffic in different ways and what sorts of advantages that might bring us. And then obviously the demo at the end, and of course some time for Q&A. So anything that comes up, feel free to throw it in the chat. We have people there, and then Ashish and I will do our best to also field questions live at the end of the presentation if there's still anything left that you're wondering about. Okay, so for the quick Azure Firewall overview, if you want a full overview of Azure Firewall, we're assuming in this webinar that you have probably been with us for other ones of these and that you already know what Azure Firewall is. Maybe you're already using it, but if you need an in-depth overview of Azure Firewall, check out our previous webinars. As Valen mentioned, there's a link to that for the webinar recordings. We've done several firewall webinars. So just as a very, very brief recap, Firewall is our Firewall as a service. It's a PaaS service that lives within an IaaS environment. And so it will give you the ability to direct and control and inspect any traffic that you send to it. Some of the new features that we have with Azure Firewall Premium include TLS inspection, IDS, IPS, and using full URL and categories to direct your traffic. The topic that we're going to talk about today is not dependent on Firewall Premium, though. So you can use this set of features with Azure Firewall Standard or Premium, and there will be in the future some extra benefits toward using it with Firewall Premium, but we'll get into that as we progress. So I'm not going to go into much else on this. So I will go directly into our main topic. So by default, what happens to DNS traffic in Azure environments? We're going to take a very simple example here of a VM that just exists, with default configuration settings. If you spin up any virtual machine in Azure, this is how things work. So the way that virtual machines in Azure are configured to use DNS name resolution is set by the settings on the VNet. And the way that it works by default is that we're using Azure DNS. So it's default Azure provided. Any virtual machine, and these are handed down to the virtual machines, by the way, via DHCP. DHCP is a service that it just exists as part of our VNets. And so any virtual machine that is started up for the first time in Azure will get its IP configuration, which includes its DNS servers from the DHCP service that exists within those VNets. And so when this virtual machine spins up, it will go to Azure DNS for all of its name resolution needs, and then it will go straight out to the internet. Not pictured here, but you may have NSGs in the way that limit traffic in one way or another. There's no extra hop. There is the VM goes straight out to Azure DNS for name resolution. Once it resolves the name to an IP address, the web request goes straight to the internet, straight to that IP address. Pretty simple. Now, thinking about how this is assigned via DHCP and via the DNS settings on the VNets, there's a few different ways that you can change this behavior. You can change this by using your access to that VM. So as anybody knows, if you just log into, let's say, a Windows server, you can go and assign, you can change the adapter settings of that machine, and you can tell it to use a static IP address, and you can set its DNS servers there, and that will work. That will change the settings of that machine. There's a couple other ways that you can do it just directly through the Azure portal. You can either change it here where it's pictured on this slide, which is the settings of the VNet, or you can also change those settings on the network adapter object, the network adapter resource type within Azure. So you can do a few different things to change this behavior, but if you don't, this is how it works. Ashish probably will get a chance to demo at least one of those methods when he demos all of this. Now, just a quick primer on how we change the flow of traffic. So we talked about how we might change some of the settings on that tell the machine where to go for name resolution. Now, how do we actually change the flow of the traffic? Instead of telling it to go straight out to the internet, one of the fundamentals of setting up an environment for Azure Firewall or any other network virtual appliance that you might want to use is using routes to force traffic instead of going straight out, forcing traffic to go to a specified next hop address. This is done with route tables associated to subnets, and the routes that route table contains will contain a source and a next hop address. So for any machine that lives in the scope where that route table is assigned, so it's assigned in this case to the subnet that contains a virtual machine, that route table is going to say for any traffic, and you can make it very broad. You can use like 0.0.0.0/0, saying that for any traffic leaving that virtual network, it will go to Azure Firewall as the next hop. Now, in this example, these are two subnets within the same VNet, so we might have to be a bit more specific on, we want to say any traffic that even lives in the same VNet but is leaving the subnet will go to Azure Firewall and then out to the internet. So this is the fundamental of how you direct traffic to Azure Firewalls, because if you're, and again, this applies to more than just Azure Firewall, but to any virtual appliance that you would like to designate as the next hop for network traffic. This is routes and associating to subnets is how you do that. And that now in this diagram, you can see it means that this VM can no longer communicate directly out to the internet, and we are forcing any traffic that comes from it to a central inspection point, which in our case here is Azure Firewall. So that's important because for the most part, if you have Azure Firewall in place, you want to do a couple of things with the traffic. You want to make sure that it's inspected the right way and it's directed through that central point, so that you have not only that traffic subject to a central rule set that's important to your operations and security teams that maybe lock down the traffic to just least privileged access, but it's also enabling central visibility. And that's a key theme that I want to keep in mind here. Is visibility is key. It's one thing to direct and control traffic. That's great. But security teams are also, of course, in the business of monitoring your environment with the data that is generated from this stuff. And so Firewall, in this case, acts as a great central point to log any traffic that is leaving your Azure environment. And that's a key concept to keep in mind as we're going to keep coming back to it. Going beyond the controlling routes, we're going to use the same diagram as an example. In the default configuration of Azure Firewall, so you have traffic coming from your virtual machine, hitting Azure Firewall as its next hop on its way out to the internet. We're talking mostly in this case about traffic that is externally bound, but we'll get into a little bit more, and I think Ashish will show you what might happen if you're using, let's say, internal DNS for name resolution within private networks. We're gonna right now let's concentrate on external DNS names and how we might resolve those, and then eventually send traffic to them. So in its default configuration, Azure Firewall uses Azure DNS the same way as a virtual machine would to resolve names. And so Azure Firewall is going to resolve the names of anything that is in its application rules and figure out where to send that traffic. And the thing to keep in mind here, and this is something that is kind of an aha moment for a lot of customers that realize this, and it was for me when I realized it. But when you route all of your traffic to Azure Firewall, I don't care how granular you make that route. Even if you, in our case here, we have a very specific route that says any traffic, and I don't care what the traffic is, it goes to Azure Firewall on its way outbound. DNS traffic does not get affected by that route. And so that very bottom blue line that denotes name resolution from the virtual machine, that is not affected by our routes. That traffic is not forced through Azure Firewall by default. That traffic goes straight out to Azure DNS. Now, it's not necessarily a security hole in most cases, because once that name resolution takes place, the traffic still has to flow, and the traffic, the actual, let's say, a web request, will still go through Azure Firewall. So it's still centrally managed, subject to your firewall rule set, centrally logged, all those things that you care about. The web request itself is subject to at least threat intelligence on standard and premium firewall, is likely also subject, if you're using Firewall Premium, it might also be TLS inspected, IDPS applied to it. So there's still many security layers that get applied to traffic that go out through Firewall. But the hole in this case to some customers is the fact that all those DNS queries, that traffic is just, it goes nowhere. It goes out to Azure DNS. And one of the things to know about Azure DNS is that it doesn't actually provide query level logging to the users of the service. So if you're sending traffic out to DNS, out to Azure DNS, you don't get a log of those requests. So it's a potential blind spot in terms of what security teams are able to monitor for. So this is a very important slide, and especially that, again, that bottom blue line of DNS requests going straight out. This is something that that needs to be addressed in certain circumstances to complete that scope of visibility that you have. So moving ahead, how do we do that? The first piece, and I think the most essential piece to configure in terms of DNS settings on Azure Firewall, is configuring DNS Proxy. What DNS Proxy does on Azure Firewall is it opens up Azure Firewall to listen on port 53 for incoming DNS requests. And that's, in terms of the firewall, that's all it does. You have to do there's another step in this process to make sure that you actually send the DNS traffic to Firewall so that it can then relay the requests onto Azure DNS. So if you see the only difference between the last diagram and this diagram is that bottom blue line is now staying within Azure, hitting Azure Firewall, and then Azure Firewall sends those queries out to Azure DNS on behalf of those clients. So DNS Proxy needs to be configured on the Azure Firewall resource. That's one step. The other step is to reconfigure your clients to point instead of to their default configuration, which is Azure DNS, or maybe some other custom configuration that you have. You need to point those clients to Azure Firewall as your DNS server. So Azure Firewall will have an internal IP address. That's the IP address that you're sending all of your traffic to Firewall via your routes. Now you need to do the second step of setting the DNS server on your client machines to that same internal Azure Firewall IP address. And that will make it so that any web request, the full end-to-end process of that web request, including the name resolution that happens before the actual traffic, that goes through Firewall as well. And so this is the key right here to keeping to allowing your setup to centrally log everything, not just the web request, but now you have a log of the DNS request and then the web request. And now you can start doing interesting things like comparing, let's say successful DNS requests versus unsuccessful, attempts to actually go to that traffic. Or you can catch potential exfiltration events by looking for DNS requests without a subsequent web request. So there's a bunch of different ways that you can use that logic, but the key here is just to get the data in the first place. We won't go a ton into what you might use that data for. That'll be another topic that we can dive in deep in a subsequent session. But this right here, this is the key to getting all the data for all of your web requests logged in a central place. Now, the second concept of Azure Firewall DNS settings, which is independent of the first setting, and I want to stress that point, is custom DNS for Azure Firewall. So in this scenario, in the diagram that we have here, we have Azure Firewall, instead of pointing to Azure DNS as its name resolution service, Azure Firewall is able to be configured to point to anything else, and that could be another external DNS provider. If you have a favorite, or something that you use that is external to your Azure environment, that can be any public DNS endpoint, whatever you want to use, or it can be something that's internal to your network. So in this case, we've got Azure Firewall pointing to a virtual machine, Windows DNS server, that is going to provide name resolution, and of course that DNS server will forward external requests, out to a public DNS provider, potentially Azure DNS if that's how you have it configured. But for internal name resolution, this is very advantageous, because now you get the ability to have Azure Firewall resolve internal DNS names that you can now use in your network rules to direct traffic from FQDN to FQDN that are internal to your own network, that Azure DNS would have no idea what it is. In this configuration, again, we're with this one, we have the option to either use custom DNS on its own or pair it with DNS Proxy. Now, the right way to go, the recommended way to go, is to use them both in conjunction. I think the way that the order of the slides and the order of the architectures that we presented here, I think, are probably in order of importance. I want to stress DNS Proxy for being probably the most important piece that we're talking about here, because it does, it sends all the traffic through firewall in the first place, and then you have the option then to customize which DNS provider your firewall is using for its name resolution. In this case, you do have the option of saying, well, we don't want, you could actually, you can see the dotted lines in the diagram. You can either send your DNS traffic to firewall via the proxy setting in conjunction with custom DNS, or you can allow your VMs to just query their internal DNS server themselves without going through firewall. There's some challenges to that second approach. There are instances where your firewall and your client may return a different IP address, a different resolution for the same FQDN, and that could cause inconsistent or problematic behavior of your network rules. But for the most part, that shouldn't occur as long as you do the recommended approach, which is just send that traffic to Azure Firewall. There's no reason to send it directly to the DNS server that's internal to your network. If you have latency concerns or something like that, maybe there is there's a potential reason to want to do it the other way. But our recommendation is enable proxy and enable custom DNS on top of proxy. Custom DNS should probably not be implemented without also using proxy. And then finally, what this enables, so with these two pieces stitched together with both custom DNS, if you choose for that, but at least DNS proxy, this is going to allow you to enrich the data that Azure Firewall is already producing via its diagnostic logs. So without DNS proxy enabled, you're going to be logging, of course, your application rules and your network rules and your threat intel matches. And if you're using premium, you're logging your IDPS matches and the full URL of your web requests. And now this just augments that data with yet another category, which are the DNS proxy logs, which will show you all the details of the DNS requests that are being forced through that firewall. So it's another big chunk of data that otherwise you would have been blind to had you not had DNS proxy enabled. So Just like any other diagnostic log, and we've talked about this on our webinars and at length, but you can use Azure Storage accounts for long-term archiving if it's something that you just want to send there for historical purposes, for compliance reasons or whatever else. Or you can use event hubs, which are the best use case for external SIEM integration. Or, of course, our favorite thing to talk about would be using log analytics in conjunction with Sentinel, so that you can start doing some more meaningful detection based on the log data that's been generated. And this is another thing that we'll concentrate a little bit more on in the demo portion. But to sum up, and this is actually the last slide that I have for the presentation portion, because I want to make sure that we're doing justice to the actual setup in the demo and giving some time for Q&A. But the main takeaway here is that even when you are routing all of your traffic, or quote unquote all of your traffic, through Azure Firewall with UDRs, the thing that most customers, I don't know about most, but at least some customers that I've talked to have not realized, is that the DNS traffic that are originating from your client machines still does not go through Azure Firewall. So it's not a comprehensive, it's not forcing every single piece of traffic through that firewall, unless you do, some extra steps, which is configure the Azure Firewall DNS proxy, and then the other essential piece is to configure your VNets or your network adapters or your VMs, guest OSs, to point to Azure Firewall as their DNS server, which will then forward the DNS requests on behalf to whatever its configured DNS provider is, whether it's the default of Azure DNS or whether you've customized that DNS to use something internal or your favorite external source. So with that summary, I will hand over to Ashish, and I think Valen might have something to say between us. So Ashish, I'll let you share your demo, and we'll change over.
Yes, what I have to share is actually a link that I just created for the folks to raise their questions. Looks like we lost our native Q&A here in Teams. So please post your questions or comments at aka.ms/webinar-Q&A, and we'll keep it rolling there. And Ashish, if you want to move forward, please take over.
And Valen, it looks like I still have access to the Q&A. So I guess while I was presenting, it didn't break for me yet. So I'll see if what I can do on answering some of the outstanding questions.
Great, thank you.
Right, thanks Anthony, and thanks Valen. I hope you guys can see the screen. And yeah, so I just wanted to kind of give you an overview of the custom DNS and the DNS proxy capability in Azure Firewall. And this is the scenario which we have at the moment. So I've got this VM Win 2019, which is my domain controller, and also a DNS server. And then I've got a VM Windows 10, which is part of the domain, and another VM Windows 10, which is part of the workgroup. And again, I'm using UDRs to push all the traffic through Azure Firewall. So if VM Win 10 or Win 10 domain has to communicate with 2019 or vice versa, everything goes through the Azure Firewall. So it's basically the spoke and hub and spoke topology, the common one. But yeah, the main thing is that this is the DNS server, which we have, also the domain controller. So as I was saying, so this is our VM Win 2019, which is the domain controller. So there are kind of couple of ways where you can specify what DNS server you would like your virtual machine or your infrastructure to use. One way to do that is to specify the DNS on the virtual machine network itself. So if I go to the NIC card for the virtual machine, I have this option right here, which is DNS server. And in here, the default option is inherit from virtual network, or you can set custom. So what I've done is I've set it to custom, and I'm saying that if my domain controller has to resolve the names, then it can connect to Azure Firewall. Now, this is one way of specifying the DNS server. And the other way is you can specify it on the virtual network. So if I go back to my VM, and if I go to my virtual network, which is right here, this is the virtual network I've got, and I can specify the DNS server right here. I haven't done that because what I'm trying to show you here is that that I'm trying to use the custom DNS on the Azure Firewall, and the custom DNS is the domain controller which I have, using which I can resolve both internal and external name. But you can always specify the DNS server settings right over here, and you can say whatever you would like the DNS server IP to be. So that's the first thing. That's the two options which you have to specify the domain control, DNS servers. Now, coming back to how do we configure this on the Azure Firewall. So this is my Azure Firewall policy, which is connected to my Azure Firewall, which is Demo Firewall Premium. And you can see the policies right here, Policy Premium. And also, I just want to highlight that the private IP of my Azure Firewall is 192.168.0.4. Okay, so if I'm going to configure, or if I'm going to enable a DNS proxy capability on the Azure Firewall, this is the IP which all my clients, my VMs, or all my infrastructure will point to as the DNS server. As I highlighted right here, that on the domain controller on the network interface, you could see that the DNS server which I specified is 192.168.0.4. So coming back now, from the firewall perspective, you have to configure DNS over here. So by default, it is set to disabled, right? But you can when it's disabled, what that means is that Azure Firewall is using Azure DNS to resolve the names, right? So if there is no requirement saying we do not want Azure Firewall to resolve the internal names, then you can just go with the Azure DNS, which means that Firewall will still continue to use Azure DNS, but it will use it can only resolve the public names. Now, the capability which we are trying to get here is the logging for the DNS traffic from our Azure infrastructure. And if you're going with that option, then we have to enable the custom DNS on the Azure Firewall. And then you have two options. Either you can go with default, which is the Azure DNS, or you can specify custom. So for our demo, what I've done is I've specified custom DNS, which is the IP of my domain controller. So this machine right here, you can see this is the primary IP, which is 10.0.0.4. So I've said, or I've configured Azure Firewall to say if you want to resolve internet names or internal names or any DNS query, you have to connect to 10.0.0.4, and that will resolve the names for you. With this, you also, like as Anthony emphasized, that we should also be using DNS proxy feature, because if we do not enable DNS proxy, then the traffic will not be the DNS traffic, like the Azure infrastructure or all my VMs cannot use Azure Firewall as the DNS server. So I have to enable the DNS proxy and enable it. Now with this, the configuration from Azure Firewall perspective is complete, right? So I've specified the DNS server which I want Azure Firewall to use. I have also enabled DNS proxy capability so that the Azure infrastructure or the VMs can use Azure Firewall as the DNS. Once I have enabled this, it unlocks a very big capability within Azure Firewall, which is to use FQDNs, right? So right now in here, you can see that I have specified in my network rules FQDNs to connect to. So I've not specified the IPs, but I said if anyone from this source network want to connect to this particular machine, then I've specified the FQDN and not the IP address of it. What this gives me is that if tomorrow I'm adding more IPs on this host, or if I'm changing the IP, I do not have to worry about my firewall rules, right? Because I'm using FQDNs. So this is one of the big capability which you have in Azure Firewall of using FQDNs, not just internal FQDN, but also you can use public FQDN like ntp.time.com, or you can specify different FQDNs right here. Again, as you may know, with network rules, you can specify individual port and protocols, what you would like to allow. For this particular demo, what I've done is I have allowed TCP and ICMP. So TCP 3389 so that I can do RDP to my Windows 10 machine, and ICMP to just show you the ping. Now coming back to my VMs, again, this is my VM, which is the domain controller. This is my VM, which is a workgroup machine, Windows 10. And over here, I want to just highlight the DNS settings. So on the Windows 10, which is the workgroup machine, if you look at the DNS server, I have specified 10.0.0.4. So what I'm saying to this Windows 10 machine is that if you want to resolve the name, then you are connecting directly to the domain controller, right? So I'm not pushing this traffic, the DNS traffic through Azure Firewall, right? And the reason why I'm doing this is to highlight if you are not using the DNS proxy capability, and if you're not pointing your VMs to the Azure Firewall as DNS server, then there is a chance where an A record resolves to multiple IPs. Then firewall may resolve to a different IP address, and your VM will resolve to a different IP address. And if that's the case, then firewall will not allow the traffic because the IP is different, what the VM resolved and what the client resolved. And I'll show you that as well. Now, this is my workgroup machine, VM Windows 10. And then this is my Windows 10 domain machine. And again, if I look at the DNS settings here, you can see that I'm pointing to the Azure Firewall. So 192.168.0.4 IP, which is my Azure Firewall. So both my domain controller and my domain machine is pointing to Azure Firewall as a DNS server, whereas my workgroup Windows 10 machine is pointing directly to my DNS server on the domain controller. Now I'm connected to my domain controller using Bastion, and this is the DNS server which I have, and you can see that both my domain controller has multiple IPs, and same with the Windows 10 domain machine, which has multiple IPs as well. Okay, the reason why I have multiple IPs on this one, because what I will try to repro is that on my workgroup Windows 10 machine, when I'll try to ping the domain Windows 10, then firewall will also resolve the same name. And if it resolves to, like, for instance, 10.0.0.14, whereas my client, Windows 10 client resolves to 10.0.0.7, then ICMP will not work because there is a mismatch in the name resolution. And that again shows the importance of pointing your Azure infrastructure to Azure Firewall as a DNS server. Okay, so this is my DNS server, and the domain which I have is called fabricam.local. Once you install the DNS server, and if you look at the forwarder, by default, that forwarder is pointing to Azure DNS. So this is how my infrastructure or my DNS server can resolve both internal and public names. So anything which is not fabricam.local is forwarded to the Azure DNS, and if it is a public DNS name, then it will resolve it. So just wanted to highlight this. So I haven't added this. As soon as I install the DNS, this gets added directly. Now, going back to my VM Windows 10. So this is my workgroup machine. See, this is the workgroup machine, and if I do IP config all, you will see it is pointing to 10.0.0.4, which is my domain controller. Now I'll just show you, if I do NS lookup, it is connecting to my DNS or domain controller. And if I say fabricam.local, it can resolve the name. And same if I try to resolve the name for VM Windows 10 domain VM, it is resolving to multiple IPs right here, right? Now, if I go and ping VM Win 10 main fabricam.local, as I showed you, there is a rule in the Azure Firewall to allow the ICMP traffic, but now it depends whether both firewall and VM will resolve the same to the same IP. If it resolves to the same IP, then the ICMP will be allowed. Then I'll clear the DNS cache, and then I'll see if I can repro the issue. Right, so both of them are resolving to the same IP. So if I go back and say flush DNS, and now if I try again, so now it's again doing the same thing. Let's give it another try. Do it. Yeah, so I haven't got anything. Yeah, I have to do it multiple times just to see if I get lucky and both firewall and the machine resolves to different names. So if I say IP config, let's do this. Let's look up. If I say VM win10 dash domain dot fabricam dot local. So if I've got these IPs for that machine, if I say ping 10.0.0.14, yeah. Yeah, so at the moment I cannot reproduce it, but if you have that mismatch, then you will see that the request will be timed out here. So moving on, the other bit which I wanted to show you is the logging feature. So as we are pointing the VM to the Azure Firewall as the DNS server, what that gives me is the logging as well. So we got a couple of ways to look at the logging, but over here in the diagnostic settings, this is where you have the DNS proxy config or the category. So this is where all the DNS traffic, when you're using the custom DNS and the DNS proxy capability, you will see the traffic in this category right here. Now I'm forwarding it to my log analytics workspace, and in my log analytics workspace, this is the query which I have. What I'm saying is Azure Diagnostic, where the category is DNS proxy, and then parsing the message to show what traffic is coming in. So this is like, I can just run it again. And this will show you all the DNS queries which came to the Azure Firewall for the name resolution from the VMs. So in here, you can see that internal names, plus you could see the external name, and you would also see what were the details, in the sense the DNS request, what it requested, and whether it was successful or the name cannot be resolved. So you get all this information in the logs, and it gives you like whether we are trying to do IPv6 name resolution or IPv4. So you will see all that in here. The other way to look at all the logs is through the web, through the workbook. So this is the workbook which is readily available on our GitHub repo, and you can download it from there. And if you're using Log Analytics Workspace, then you can configure this workbook directly on the workspace, as I've done it right here. And in there, you can see all the logs based on, you can set up the time range, whatever you want to see. So if you just say last 5 minutes, what it does, it picks up the traffic, the logs from the Log Analytic Workspace and give you a visual view of this. And you would be able to see what all names the clients were trying to resolve, how many DNS queries were coming in from individual clients. Plus, you would also see the raw logs, which I just show you using that query, and you would be able to see whether there were any errors in the name resolution for a specific domain. So yeah, so this is kind of give you all the information. And if I say just show me anything for 0.7, you can always filter based on that particular node as well. So yeah, that's pretty much what I've got for you guys. Anthony, do you want to add anything, or do you want to show anything different?
No, I mean, I think we hit all the points, and I'm trying to see if there is anything, I know we've had a little bit of issue with Teams Q&A, but I'm pretty sure anybody that was able to ask a question, with the technical difficulties, I think we've addressed all of them. If anybody out there has last minute questions, please feel free to throw it in the live event Q&A if that is working for you. And then if not, go ahead and post it in the forum because we're monitoring that too. Let's see, I do see one question, so we'll field this one live. Can we have the DNS server, assuming the DC, on the hub VNet? And if not, why? Do you want to take that one, Ashish?
Yeah, you can place the DNS server anywhere, hub or spoke or even on-prem, as long as Azure Firewall has a route to get to that particular DNS, you can use that. So if it's in the hub network, then I'm assuming that it's in the same VNet, then the traffic should be directly allowed. And if you want to use your corporate DNS, which is on-prem, you can always configure the route for the Azure Firewall to connect to your on-prem environment, and you can use that.
And I think, unless any other questions come in the last couple of minutes here, I think we've got them all.
Yeah, sorry for that technical difficulties, but looks like we did capture quite a bit, or quite a bit of questions got in, and thanks for the great feedback as well from the audience. Let's try to recap on this, and perhaps we'll look at it once again before we end it if there's any additional questions. Just a few reminders I wanted to post out there to the listeners, that the best way to ensure that you don't miss any future webinars or major announcements, please visit our landing page at aka.ms/security community. And while you're there, you can find the easy ways to navigate and find resources and learning content relevant to our security products and the communities around. A good start, I think it would be by just simply browsing the bit-size product videos, as well as the past webinars that we've done, Ninja trainings, GitHub communities, and more. And also just a reminder to please submit your feedback on how we can improve on these webinars. And you can do that by going to aka.ms/security webinar feedback. So just going back to look at it and see if we have anything in tech community as far as last minute questions. No, we're good. Well, thank you so much, Ashish and Anthony, for this excellent presentation. And also, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.